Hey, let's greet each other properly. Good morning. It's Mr. Ainsworth. We're going to get right into section 8.3 here and learn how to translate sine and cosine waves, and we're going to take this into parts, this being part 1. Before we do, though, let's get into a little review from last lesson here, and let's graph 1/2 cosine of 2x, and then we'll graph 3 sine of pi x. Now remember our general forms. Let's put them at the top. Y is equal to a cosine of bx, where a is the amplitude and b affects the period. And our other general form is a sine of bx here. Remember, a stands for amplitude. So in this one here, a is obviously 1/2, b is 2, so this is a, and this is b. And if b is 2, that means the period is 2 pi divided by b in general. In this case, it's 2 pi divided by 2. All right, so the period is equal to pi, obviously. So what we do is we scale the axes first. Let's go up 1, down 1. Our original cosine wave goes, oscillates or bounces between -1 and 1, but this one bounces between -1/2 and 1/2. The period is pi, so I'm going to go out 4 units. Call that pi instead of 2 pi, so we can graph one period. And I break it up into 4 equal parts. Okay, and to graph the wave, we know cosine is 0. Excuse me, if x is 0, 0 times 2 is 0, cosine of 0 is 1, 1 times a half is half. So it starts up here. It goes down to the axis, and then at pi halves, down at -1/2, then back up to the axis, and then here. All right, you don't need to plot points. You just need to know your basic way to graph cosine, and then you plot your 5 points. Remember, we always plot 5 points. Plot 5 points total. Again, with 5 points, I'm talking about this one, this one, this one, this one, and this one. Okay? So, on this one here, a is 3 and b equals pi. That means p, the period, is 2 pi divided by pi. In this case, the period is now 2. Okay, and this thing oscillates between 3 and -3. So, -3 here, +3 here. I'm going to go out 4 units and call that now 2 because that's the period length. Okay, and then I plot. Sine starts at the origin, so, and then I go up, and it comes back down, and then back down, and then back up. Okay, that's one period of sine, or in this case right here. This is 2 right here. That's one period length. If you want to graph more than one period, you just repeat all these points and go out to 4, from 2 to 4. Okay, let's get into our new lesson today, section 3. We're going to again translate our sine and cosine functions around the plane. So our general form now looks like this. Right here, y minus k equals a times the sine of b times the quantity of x minus h, and the other one's in terms of cosine. So the question is, how do you graph functions like this, and what do a, b, x, and h and k stand for? So let's go through an example here together, and let me define a few things as we go. What we want to do is we want to determine or define the period, the amplitude, the shift, the wave axis. And what I'm going to do is I'm going to do that as I describe this wave right here. We call it a sine or cosine wave. It's actually both. You can express it either as a sine wave or cosine wave. And show you how to define the period and figure out how to look at the graph and determine the period, determine its amplitude, determine how it's shifted for the sine and shifted for the cosine, and what the wave axis is. So we start off with the period. So let's define the period as follows, and we're going to define it as the distance between successive maximums or minimums. Okay, so it's the distance, all right, between successive maximums, okay, or minimums. Oops, that's 2 C's in there. Okay, so the period is the distance. Okay, highlight the word distance there. So the distance here between, let's say, this point, here's a max, and here's another max. What's this distance right here? All right, and we look down, and we see that that's 3. We look down here, and we see that that's, oh my gosh, so small. It's 11. So what's the distance between the 11? Okay, 11 minus 3 equals 8. All right, so the period is equal to 8. So 8 radians in this case. Period length is 8. Now, what's the amplitude? Well, the amplitude is the distance above the wave axis. So let's draw the wave axis first. Okay, so let me see, you're at height. You see it's at height 5 right here. Height 5, and it's going down to -1. Okay, the wave axis, it's got to be in the middle of those two values, and the way you find the middle number is by averaging. So let me define the wave axis now. The wave axis is found by averaging, because it runs right through the middle of the wave, and middle number is the average. And the way you average is you take the max and add it to the min, divide by 2. So it's the average. Okay, and that's equal to max plus min, all right, divided by 2. For us, it's 5 plus -1 divided by 2, and that gives us 4 divided by 2, or 2. So my wave axis is y equals 2. It's always y equals k in general. Okay, so y equals k in general. So let's graph that as a horizontal line. See if I can do that really well here. Right, y equals 2, there we go. Now let me make this a little bit shorter. There we go. Okay, so there's my wave axis at y equals 2. It runs right through the middle of the wave. Wave axis, WA. That's my abbreviation in my notes. Wave axis, it's y equals 2. It runs right through the middle of the wave, and what it does for you, it helps you identify and see the amplitude, because the amplitude can be seen here, here, here. Okay, these are the amplitudes, okay, and they're all the same. So what's this distance between, let's say, 2 and 5? Okay, well, obviously it's 3. So amplitude is 3. You can also see the distance here between 2 and -1 is also 3. So the wave axis helps us see and identify the amplitude. And the amplitude is found by taking the distance between the max and the min and dividing by 2. To get the distance, you've got to take 5 minus the -1. So the max minus the min. So max minus the min, divide that by 2, and it's going to be representing the distance above the wave axis. So distance, okay, above the wave axis. Okay, and for us, it's, let me see, the wave axis, the amplitude here. You see 5 minus a -1. Divide that by 2, you get 6 divided by 2, or 3. So notice the amplitude is 3. It corresponds to visually, that is 3 units above the wave axis, and the calculation is the same. The wave axis here, in general, it's y equals k. I should put that in red. Talk about that in a minute. But in this case, it's y equals 2. Okay, now the only other thing we need to figure out is the shift. Okay, and the shift in general is h comma k. It tells us how many units left and right to go, and then how many units up and down to go. Okay, and the shift, h comma k, or the translation. So the question is, what's the shift for the sine curve, and what's the shift for the cosine curve? All right, let's talk about that. So, so what do we have first? We need to figure out the our coefficient b, because remember that's affecting the period. So what's b? Well, we know that the period in general is 2 pi divided by whatever b is. So if we know the period is 8, I have 8 equals, well actually, you know what, let me solve for b here, because if I do that, I got to multiply both sides by b, and I get, right up here, I get bp is equal to 2 pi, divide by the period. Oh, okay, there we go. I get b is equal to 2 pi divided by the period. So if I want to figure out my coefficient b, I just take the period and divide it into 2 pi. Okay, so let's highlight that right here. So that I know, and I know this right here from the beginning, from prior lessons. Okay, so since the period is 8, I've got b is equal to 2 pi divided by 8, so b is equal to pi fourths. Okay, my amplitude is 3. That's true by looking at the graph. We also calculated that. So the only thing I need to do is figure out the shift for sine. Okay, now an untranslated sine graph with an amplitude of 3 and b is equal to pi fourths looks like this. Y is equal to 3 now, sine of pi fourths times x. Okay, that's an untranslated sine curve with b equals pi fourths and a equals 3. And we know that this function right here starts at the origin generally, okay? Because 0 times pi fourths is 0, sine of 0 is 0, 0 times 3 is 0. So it starts at the origin. All right? So, but this sine wave has been translated off the origin. Now, whereas before the sine wave was the x-axis, excuse me, the wave axis was the x-axis, now the wave axis is above. It's at y equals 2. And we notice that it crosses the wave right here, and here, and here, and here, and here, and all these points. Okay, so what we want to do is pick one of those points to start the sine curve where it goes up and then back down. Because remember the sine curve, let me just draw a little sketch right here, it goes like this. It goes up and then back down and then back up again. So what we want to do is find an up portion. Now if I use this point right here, it goes down and then back up. Okay, so this is not a good point, so I'm going to put not a good point there. All right, this point, however, it goes up and then back down. So the question is, how do you get from the origin to this point here? This is a good point to start the sine wave. This is another good one right here. So the question is, how do you get to that point? How do you get from the origin, which is where you start the sine? In fact, let's signify that. Let's write that down. This is where you start sine. How do you get from the origin to this point here? And obviously you got to go right and you got to go up, and that's your shift. Okay, we have to go right 1 and up 2, so 1, 2. So my shift for sine in this case, my shift, let me just go get some more room here. My shift, which is your h, k, for sine is 1, 2 in this case. And if that's the case, then I get y minus the 2 there, because k is 2, is equal to a, which we know is 3, times the sine of b, which is pi fourths, times the quantity x minus 1, because h is 1. That's how I write the sine curve in terms of sine. Okay. Now you can also figure out the shift for cosine, because you can the cosine curve or the cosine wave is just a shifted sine wave. So if I change the shift, I can write it in terms of cosine as well and have the same graph. And we can verify this on the calculator as well. Now the cosine curve does not start at the origin, as you guys know. Cosine curves start at where the amplitude is. It goes down and then back up and then back up again. It goes down and then back up. So where does it, and by the way, the typical place to start is 0, 1 if the amplitude is 1. But our amplitude has changed. We have y equals 3 times cosine of pi fourths x. So an untranslated cosine curve starts at amplitude with 3, so at 0, 3. So let me switch to green here. We go up 1, 2, 3 right here. This point is where cosine starts, at 3. Okay, and now notice also that cosine starts at the top of the hill, all right, the top of the wave, the high point, the max. And then we look for a down portion. So what we have to do is to get from 0, 3 to a max. So we got to go right, okay, and then up. The question is how many right and how many up. And if we figured that out, we got the shift for cosine. So notice here that we got to go right 3. So right 3, and then from 3 to 5 we got to go up 2. So right 3 and then up 2. So my shift for cosine is 3, 2. Okay, so 3, 2, that's h and that's k. So the way I write cosine curve is y minus 2 is equal to 3 times cosine of pi fourths times quantity x minus 3. If you graph both of these curves on the same set of axes, they will overlap because they are the same. The graphs of these equations are the same. Even though one's written in cosine, the other one's in terms of sine, they're the same waves. Okay? It's just that the cosine wave is just a translated sine wave. That's all it is. So your job in this section is to learn how to write it in terms of sine and in terms of cosine by determining the period, the amplitude, the shift, and the wave axis. Also notice my shifts. 3,2 for cosine and then 1,2 for sine. Notice the k value. K is 2 here, k is 2 here, and I said the wave axis is always y equals k. Alright, that corresponds. So when I give you a sine wave or a cosine wave, and I ask you to figure out all four pieces, which we will later on, you can easily identify the amplitude, b, and the shift, h, k, just by looking at the function. We'll do that later. Alright, one example is not enough, so let's do it again. And let's determine what we have for this one, okay? Because this is a different sine and cosine wave with a different period, different amplitude, and so on. So the very first thing I have my students do, or what I do, is again draw the wave axis. And it's height 4 here, and it goes down to 0 here, so the wave axis is at y equals 2. And that's the first thing I draw. And so it helps me see things more clearly. So get your straight edge out, draw a wave, or excuse me, a horizontal line at 2. Let's label it y equals 2, and that's your wave axis. So y equals 2. It's a horizontal line. The amplitude is here, from 2 to 4. A is 2 there, so boom, amplitude is 2. The period is here, from 0 to 4, so period equals 4. So you can see how easy it is when you're given the graph and you're given nice values. It's fairly easy after some experience to determine these things. The hardest part is the shift, and getting used to knowing how to use the shift. Okay, let's talk about the shift for sine first. And the shift is h, k in general. Now sine starts at the origin here, so sine starts here. So, and then remember, you got to look for the sine curve where the wave meets the axis. Excuse me, where the wave meets the wave axis. So it meets it here, 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 and here. And what you're going to do is you're going to look for an up portion. So that's a good point to pick because it goes up and then back down. This point goes down right here, so this one's not good, okay, to pick. Put a little sad face right there. This point is good right here because it goes up and back down. And typically we pick the one in quadrant 1, the shift in quadrant 1, or you can pick the shift in quadrant 2. That's cool too. But typically you pick it in quadrant 1. All right. So let's make a general rule. Let's pick the shift, the closest point for the shift in quadrant 1 versus quadrant 2, so that we all have the same response. Because if you don't have a general rule to doing that, then your answer will vary from mine and it'll vary from the book. Okay. So let's pick this one. Actually, not here. Let's pick it right here. So this one's good. That's a good one. This is also a good one here. So how many right and how many up? So you got to go right, and then you got to go up here, and it looks like right 3 and up 2. So for my sine shift, it's going to be 3, 2. So, and the amplitude is 2, and the period's 4. If the period is 4, let's figure this out. Period equals 4. B is equal to 2 pi divided by the period, and that means 2 pi divided by 4, or pi halves. Excuse me, pi halves there. There we go. So B equals pi halves. So we have y minus 2 is equal to a, which is 2, times the sine of pi halves, all right, times quantity, x minus h, which is 3. And that's how you write the function in terms of sine. All right, and keep in mind there's an infinite number of answers here, because I could have picked this point in quadrant 2, or I could have picked this next point right here. This would have been a good one here too as well. All right, just pick the closest one in quadrant 1. Let's make that as a general rule. Okay. All right, now let's figure out the shift for cosine. So let's write this in red. The cosine curve with an amplitude of, let me see, 2 would start at 2. So the cosine would start right there. And so the question is, how do you get to that to a max? Like this max right here. Let's pick the closest max, okay, versus this one. This one's not as close as 0.4. So how do you get from 0.2 to 0.4? And the answer is you just go up 2. So the shift is 0, 2 for the cosine curve. So my shift here is 0, 2, where that's h and that's k. So I have y minus 2 is equal to a, which is 2, that doesn't change, times cosine of pi halves times x minus 0. Okay, rewritten, y minus 2 equals 2 times cosine of pi halves x. Okay, that's how it's done. So my shift here, well, I just put my shifts down here. Okay, you got a different shift for sine versus cosine. All right, now let's try that one more time. Actually, once you pause the video, once you try it. And when you're done, press play. Okay, we're back now. And let's analyze the curve here. So let me see, height 4, low point 2. The wave axis has got to go right through the middle of this wave here, so let's draw the wave axis first. And it's at y equals 3 this time. Wave axis, y equals 3. That's the first thing I do. Amplitude is here, between 3 and 4, so a equals 1. You can see it here as well. It's the wave axis. Let me see, amplitude, where's amplitude? Right here. Well, amplitude is 1. The period length is seen to be here. What's the period? Well, let me see, from 2 to 10. So it's from 2 to 10. Period is 10 minus 2. Period length 8. And the question is, what's the shift? Okay, so let's talk about the sine first. So I could pick, I look at where the wave axis meets my curve. It meets it here, here, and here. We look for an up and then a down. So this one would be good for sine. This would be not good, and this would be good. But this one's closer. So how do you get from the origin, because sine starts here, all right, straight up to here? And the answer is you simply go up 3. So the shift for sine is 0.3, and that's h and that's k. So already I can determine my sine curve. And if p equals 8, that tells me that b is equal to 2 pi divided by 8, or pi fourths. So b is pi fourths. So now I can write the curve y minus 3 is equal to a, which is 1, times the sine of x minus h, which is 0. Simplify, I get y minus 3 is equal to the sine of x. Okay? Whoop, wait a minute. B is pi fourths. Pi fourths. Let me rewrite this better here. The sine of pi fourths x. Yeah, that's better. I knew I missed something there. Okay, and for the cosine, how do you handle that? We want to look for max, okay? Now, since the amplitude is 1, my cosine curve would start at 1. Cosine starts here. Alright, how do you get to a max? You got to go right, and you got to go up. Alright, so right 2 it looks like, and up from 1 to 4, that's up 3. So 2 comma 3 it looks like. So for this one, my shift, my h comma k, is 2 comma 3. So I've got y minus 3 is equal to a, which is 1, times cosine of pi fourths now, times x minus 2. There you go. That's how it's done, my friends. So what you guys need to do is try it on your own. Alright, so give that a shot and check the solutions. Check solutions online. That's your responsibility. If you have any questions, see me in class. I'll see you tomorrow.